We're going to talk about some special cases that happen when we're multiplying two binomials together. The first special case is when we have a square of a binomial. So like this is an example when we have the binomial 3x plus 4 squared. So the first thing you have to ask yourself is, what does it mean to square a binomial? And just like what it means when we square a number, like 5 squared is 5 times 5, which is 25. Negative 4 squared is negative 4 times negative 4, which is 16. X squared is x times x. Squiggle squared is squiggle times squiggle. So 3x plus 4 squared just means 3x plus 4 times 3x plus 4. Once you write it out like this, we have two binomials that we're multiplying by each other. So this is what we've already done before. You can use the distributive property to solve this. A FOIL is what we say we use to solve this. So first, we multiply our two first terms. So when we distribute the 3x to the 3x, we get 9x squared. Then in FOIL, we have outer. We multiply our outside terms. So 3x times 4 is 12x. Inner, 4 times 3x is 12x, and last, 4 times 4 is 16. When you combine those middle terms, we get 9x squared plus 24x plus 16. Right? Notice that your two middle terms are exactly the same. That will always happen when we're squaring a binomial. Those middle terms will be the same, and then we'll need to combine them. Basically, we're doubling what that middle term is. We have one more example of squaring a binomial. This time I'm throwing in two variables just to spice it up a little bit. So just like we talked about in the last example, 5x minus 2y squared, it just means 5x minus 2y times 5x minus 2y. So then when we use FOIL, or we distribute those terms, 5x times 5x becomes 25x squared. 5 times 5 is 25, x times x is x squared. Then 5x times negative 2y, multiply your coefficients first, negative 10, and then you have an x and a y. Then on the inside, negative 2y times 5x, negative 10xy, just like I said before, our middle terms are going to be exactly the same. Then we multiply negative 2y times negative 2y, so negative 2 times negative 2 is positive 4, and y times y is y squared. Lastly, we combine our two middle terms. So our answer is 25x squared minus 20xy plus 4y squared. Why don't you pause the video and try this one on your own? All right, what you should have gotten as your answer is 49x squared. Then as your middle term, you would have gotten negative 21x and negative 21x to get negative 42x. And your final term, negative 3 squared, is a plus 9. Go ahead and pause and try one more of these on your own. All right, so the answer, when you squared the first terms, you would have gotten 9m squared. And then your two middle terms, when you did outside and inside, were both 3mn. So together it made 6mn. And then your last term, when you took n times n, you would have gotten n squared as your last term. The next few examples that we're going to look like are going to look exactly the same, kind of like the ones we were just doing, but instead of being exactly the same, one's going to have a plus sign in the middle, it's going to be a sum, and the other binomial will be a difference. It'll have a minus sign in the middle. So we're going to go through the same steps to start us off on these. Multiply our first terms to get m squared. Outer minus 5m. Inner plus 5m. And last, 5 and negative 5 give us negative 25. All right, notice when we combine our two middle terms, we have a negative 5m and a positive 5m. Those cancel each other out, so our final answer is m squared minus 25. This is called a difference of squares, and we are going to learn more about these later on. All right, we're going to solve one more, maybe two more examples where we have a sum and a difference. But other than that, they look exactly the same. So when we multiply the first terms, we get 4x squared. Our last terms, 2x times negative 1. Our inside, 1 and 2x gives us 2x. And last, we have 1 times negative 1, which is negative 1. Notice again, just like in the last example, our two middle terms are going to cancel each other out because we have a negative 2x and a positive 2x. So our final answer is 4x squared minus 1. So you might be able to tell this already, but every time we have two binomials that look exactly the same, but one is a sum and one is a difference, you are going to get a difference of squares as your answer. Every time that middle term is going to cancel, they're going to cancel themselves out. So we're going to do one more example of that, and then I'm going to show you some practical ways you can apply this. I wanted to do at least one example with you where we have two variables in each binomial pair. Same process, 3x times 3x gives us 9x squared. 3x times negative y, so it's going to make it a negative 3, and we have an x and a y. I like to put my letters in alphabetical order when I'm multiplying monomials with two different variables. So when we take y times 3x, again, I always start with my coefficient and then I put them in alphabetical order. You could put y times 3x, but 3xy means the same thing. And then lastly, y times negative y gives us negative y squared. Positive times a negative gives us a negative. Y times y is y squared. So similarly, we see we have a negative 3xy and a positive 3xy that cancel themselves out. So our final answer is 9x squared minus y squared. So why are you ever going to need to use this in real life? All right, so here's an answer for you. Here's an example of two binomials where the middle terms are going to cancel each other out. So we would really just have a shortcut here. We can take m times m to get m squared minus 4 times 4, which is 16. Now we could have multiplied it all out and gotten the plus 4m and the minus 4m and then seen that they canceled each other out. But the reason why this shortcut can be useful is if I told you to multiply 26 times 34 in your head, then you could use one of the methods that you already know to multiply, and that's totally fine. But you could also look at this and say, hey, that's 30 minus 4, and 34 is 30 plus 4. So now I can use the same method, I guess, to solve 26 times 34. So 30 times 30, that's 900, minus 4 times 4, which is 16. And so your answer would be 884. So just, it helps a little bit with quick mental math. Do you have to do it that way? No, not going to ever require that. But in case you were looking for an application, you got one. And just in case you needed one more application with the other special case that we talked about today. So this was not the sum and difference pattern. This was the square, when we squared a binomial. And when we took p plus 2 times p plus 2, and then we multiplied it out. So the shortcut here was you square the first term, p squared. Then it's 2 times back times front. So 2 times p, 4p. You would have gotten that if you would have done the outside, you would have gotten 2p. When you FOILed the inside, you would have gotten 2p to give you 4p. And then 2 times 2 is 4. So if I had 21 squared, that would be like saying 20 plus 1 squared, or 20 plus 1 times 20 plus 1. So we can square the front to get 400. 2 times back times front. So 2 times 1 times 20 is 40. And then back squared. And then we add them all together to get 441, and that is 21 squared. Again, am I requiring you to do it that way? Absolutely not. But I know some of you like application and you like mental math, and so there is a little bit for you.